Hey guys, how's it going? It is MJ, and this video is going to be called Justification for Being an Idiot. If you're wondering what the justification for, it is my calculations and reasoning behind some claims in some upcoming videos. Instead of doing it afterwards, in case anyone has questions or if anyone has problems with it, I'm going to justify myself in this video. Basically, what I'm talking about is CO2 levels in the atmosphere being converted into temperature to find out what the temperature was in certain prehistoric eras, and using that information to figure out how cold or how warm it is and to associate body fat with it, so we can see if we can make some very muscular animals like dinosaurs who you wouldn't think were super muscular and swole, animals who you wouldn't think would be necessarily have super high body fat percentages, but actually do have some really interesting kind of out of the normal perspectives on them. Anyway, let's get into it. First off, we got context. And the context I'm going to go over here is the CO2 cycle. Basically, CO2 gets released into the air from volcanic eruptions, and when it goes into the air, it gets absorbed back into the ocean through sandstone and other stuff. You can read about a bunch of pictures. It's really cool. But basically, over time, more and more volcanoes will sprout. Here's a little Groudon for an example. If you're familiar with the Pokemon lore, basically, it's him. But as more and more volcanoes erupt, the more CO2 gets emitted into the atmosphere, looping, creating a hotter and hotter atmosphere as more CO2 rises. And over time, when all this smog, this is like the CO2 being released in smog, as you can see, it goes far. That's a space image. That's a lot. And as more and more CO2, the whole world's going to be covered in smog, and because smog blocks out the sun, we're going to hit our final context, which is an ice age period. And that's when the CO2 level is going to go down, very, very low as the world is iced over. So cold. Burr. Yeah, I have a stylus now. It's Articuno. I like Pokemon. But yeah, so this is where it brings us to our first bit of actual information outside context. But yes, so CO2 mapping jazz. Basically, this book has given me all the information kind of source, so I recommend that you read it. It's very interesting. But what I just showed you is that this is the Groudon or heating period, where when the CO2 levels are so high, it causes volcanic eruptions, the world dies, or death mode Earth, and then when it freezes over, the CO2 levels, like right here, the CO2 levels will actually be very, very low. And then for the remaining era, the CO2 levels will slowly climb. Back to this. So it's one big circle of slowly climbing CO2 levels, and the temperature is proportional to the CO2 in the atmosphere, which is true. The more CO2 in the atmosphere, the hotter it will be. So if you're wondering, how are you going to correlate these, or how are you going to get to your endpoint? Well, here's how. We're going to take a species and we'll figure out what era it is, and we'll say, hey, it exists in the fourth period of this era, so we know that the CO2 level will be higher, therefore it should be warmer. And then in the step one, we'll find out what era it is, and then convert CO2 to Celsius. And since we know the CO2 content will be, high, we know that the temperature will be also high. And therefore, because of the higher temperature, less body fat, so more muscular builds. And the second part that's important is to find out where they live, because the CO2 atmosphere could be extremely high, but if they live in our Antarctic, that's going to have a major role in it. So the next point is that we're going to figure out where this species lived. So not only time, but location. So let's say if it lived in here, so in North America, I think I just outlined Alberta, Saskatchewan, Manitoba. All right, yeah, so right here. So let's say it lived right here. We know from this graph that it would be this temperature, which then we plug into this equation, which is C equals A, which is the CO2 parts per million converted into Celsius, plus B, the temperature of the area, which we got from the last two parts. So the time and era, so what temperature it was there, let's say it's 10 degrees Celsius there, and then in B, the location has an average of 20 degrees Celsius, divided by 2, we are going to get our C value of, 15. 15 degrees Celsius, so a nice temperature. And then we plug it into here. So with our 15 degrees Celsius, so we'll put it right here, it's going to fall into one of these values. And with one of these values, we can find an associated body fat percentage. These are all very rough calculations. I wouldn't try to fact check me on this because you will see that these aren't very accurate, but they're a little true. I based them off of certain animals. But if your calculation ends up being in between this range, your animal will probably have 30% body fat, like this penguin right here. Good boy. And if you're in our range, we're going to range in between 15 to 23. So we're going to have the body fat of a cat or of a lion. Big jump, but a little weird thing to say, so I kind of regret saying it. But you'll see like animals that have a little more fat and not as much muscle, or a lot of muscle, and that contributes to wider body fat. And then as we get the temperatures hotter, the less body fat and the more muscle they'll put on. As you can see here, we have a very, very swole and very strong tiger. And yeah. So these are the calculations I'll be using for the rest of the videos, is kind of rationalizing it through here. With this pseudoscience out of the way, the next few videos will be around this, and just this math and stuff, and an upcoming video will actually be towards my hatred towards the Brontosaurus and how silly it is. And I'll go into that because, and also if you're curious to what a Brontosaurus is, I'll just draw it quickly. But it is a species that a lot of us know from very famous series like Jurassic Park, Jurassic World, but it's this very iconic, very large dinosaur that is usually seen eating from very tall trees and whatnot. And I was thinking about it, and I was like, you know what? I'm just a little curious, and I'm going to make a video about it because I have an alternative thought method to him. But prepare for some silly science and more fun videos. These are all satirical. The math is sort of out there. There's a lot of calculations, but not 100% accurate. So not 100% accurate. So try not to take this seriously. It's kind of just joking around. But thank you for tuning by, and can't wait to see you in the next videos. Bye.